Welcome to week 5 of the ACE CAD and 3D printing group. This week we're going over slicers. Last week we went over how to export your 3D model into a file that you can print, and with slicers you can turn that exported file into something that the 3D printer can understand. So basically, what is a slicer? As I said before, a slicer converts your 3D model that you exported from a .stl file to G-code. And what G-code is a language that the 3D printer can understand. If you've ever taken like a machining class, they might have taught you G-code for the machines there. They're just instructions that the machine can understand. And in your slicer, you can also set the settings you want for the 3D printer and how you want the model to be printed. And within the slicer, it also calculates how long it would take for that object to print and how much material that object would take. With they're pretty not popular, but powerful for what they are. And there's 3 popular slicers right now that most people are using. The first one is going to be Cura, which is free. It's the most popular, and it supports most of the 3D printers out there. There's Prusa Slicer, which is an off-brand of Slicer, which if you're going to use that, you're going to be using a Prusa machine, which is kind of like I'd say the prosumer type of printer. They're like the Apple company for printers. They're good, and for their costs, are pretty good for what they are. And then there's S3D, which is a paid slicer. Not many people use it anymore, but if you can get it for free somehow, it's still pretty good. But I'll be showing you how to use Cura, just because that's what the Makerspace uses, and that's what most people use. So first off, we're just going to download Cura real quick. It's free, and it's a pretty small file. It won't take too long. Just going to search Cura. Hit the first link. Download for free. Choose which your OS is. I'm on Windows. Just going to go with Windows. Download now. Save it to wherever you save your downloads. And just because I'm doing a live video, it's going to take a couple minutes, but it's a small file. And while that's downloading, when it's done downloading, I'm just going to show you guys how to set it up for the printers in the Makerspace. So 15 seconds left. Right, my download's done. Go through all this stuff. So I already have it installed, so I'm just going to hit yes, just to make it easier. Choose and skip that part. So this first part you guys can ignore since you're most likely installing it fresh. I'm just reinstalling it for the sake of the video. It's going to bring up to your wizard. Next. I agree, unless you want to read it. Choose the drive that you want to save it to. Next. And then this one this part is going to ask to choose components or kind of like what features you want, automatically it installs Arduino drivers, visual codes, something, and then open STL files with Cura. Make sure STL files with Cura is checked off. And then you might also want to check off G-code, 3MF, and object. So 3MF and object files aren't used as much, but if you're also working with Prusa file or with somebody with a Prusa printer and they use Prusa Slicer, you might want to use these just because they save a lot more data and they're smaller. And you want G-code files because when you export from this program, it exports as a G-code file, but not many programs are able to do that. So if you add the support here, you can always look back at it. So just gonna go ahead and hit install. And then this part goes relatively fast. So that's done. Just gonna finish and run it. So when this starts up, mine's gonna look a little bit different just because I have some profiles set up already. But when you first open it, it's gonna ask you if you want to make an account. You can just skip that. And then it's gonna ask you to add some printers. So for you guys, it should look like this. It's going to ask you to add a printer. What we're going to do is we're going to add a non-network printer. And then it's going to automatically come up to the Ultimaker build volumes. What we're going to click is the Ultimaker S3, and let me just double check that. Right, not the Ultimaker S3. We're going to add the Ultimaker 3. Going to hit add. And then you should get a model that looks like a bed with Ultimaker 3 on it. And that's pretty much all you need to get set up with the slicer. So just gonna close that real quick. So with that, you're set up to use the program, and you have everything set up so that when you're ready to slice, you can do it without much trouble. Back to the slide. And last week we went over designing with 3D printing in mind on the CAD side. So when you're drawing your parts and modeling them, ideally you want to keep your holes and tolerances in mind. The next thing when it comes to 3D printing would be the slicer side. And there's three things you want to consider, and that is the orientation and how the part's going to be used, any overhangs and bridging, and I'll go over these in the next couple slides and how you can, and what they are and how you can solve them in your slicer. And just to make sure why we're going over these, You want to be able to optimize your print in the slicer because it can reduce your printing time. You can go from, like, say, a 5-hour print to 2-hour print just by flipping your objects or just changing the orientation in it prints. And you can reduce your material cost. 3D printing is already kind of cheap. 1 kilogram of material is already like $20, but if you can push that kilogram as far as you can, it can last you a long time. And it also results in less failed prints, and you can avoid what's called using supports, and mainly because 3D printed material isn't recyclable for the most part, and if you do have a failed print, you can throw it out, but it kind of feels bad when you do. But so the less failed prints, the better. All right, so on to the 3 considerations. So the first one is going to be the orientation when you print. So just as a quick recap, when you 3D print, it goes layer by layer. So it's going to lay down one layer, then it lays down another layer on top of that, another layer on top of that, and it keeps going until your object's done. But because of that, you get 2 different forces you have to think about. First one is going to be shear forces, or forces pushing alongside how the layers are printed. So if I have 2 layers like this, shear forces would be pushing that layer across. So right here, the top picture here is a good representation of shear forces, where the force, is that the right one? No, it's the bottom one, that's shear forces. So I'll change that later. But, and the one on the B model, you have the force pushing along the layer line, and so there's more of a chance that that'll break because it's just stacked on, it's like a brick on top of a brick. You can just push the brick right across. But if you were to change the orientation to where it's perpendicular to the force, it's not gonna break as easily. And the next one would be tensile force, or pulling force, which is gonna be on the top here, so I'll have to switch these later. But if the force is applied to where you're like pulling on the layer lines, so let's say you're eating, like, I'd say Pringles, just because they're stacked on top of each other, you're gonna be taking it from the top. It's the easiest way to do it. But if you can't exactly take Stingles from this, or can't take Pringles from the side, so ideally, if you're applying force to your print, you want the force applied to be perpendicular to how the layer lines are oriented. Or let me find a better way to say it. Yeah, actually, so if you have a shear force where you're pushing on it, you want the force to be perpendicular to how everything is printed. And if you're something that you're pulling on, you want it to be parallel, because it's essentially like you're pushing on a stack of papers. Or actually, yeah, just keep in mind on how the force is applied and how it affects the layers of it. So, so and then the next consideration would be overhangs. And overhangs are basically anything where there's going to be an angle or a cliff where there's no material under the next layer. So let's take a T and a Y for example. Here the T, you have it's frayed at the bottom of the two hang-offs, and the Y, you have it angled. And the problem here is that obviously with the left one, the material there is fraying out and it's kind of drooping. And that's because there's nothing underneath for those layers to print on or to stack onto. So it's kind of like you're putting material on where there's nothing for it to stack on. So the first few times you do it, it's going to droop and fail. But as you keep doing it, there's something to hang on to. And the problem with that is that it doesn't look as nice. And if you're trying to print a precision part, it won't fit in exactly. It can either be too loose or too thick, or you have to clean up, which ideally you don't have to do. And the solution to this is to ideally get a better printer, but it's not feasible since not everyone controls what machine they print on. The second one would be to change the orientation of the print. And the third solution would be adding supports to the print. Ideally, you want to try changing the orientation first and then go to supports. And then I'm going to do a quick model here. Just a simple T, and then just an example how the workflow is, and then I can show how to deal with these problems in the slicer. So let's start a 2D sketch real quick. Just gonna make a T. Let's do 100 millimeters by 200 millimeters. It's not a perfect T, but it's something I can work with. There's our T. Save that. T. And then export CAD format. Do step file or STL. Save to the folder. And then we're going to go into our slicer. Going to open file. Go to the file that the STL saved into. Click that. And it is small on this, so I'm just going to scale it up to 500%. That's better. Alright. So here we have our T. So there's two ideal ways to print this. So let's say if we were to print it this way, we'd get something similar to this right here, where you have the frayed ends on the bottom. Now there's two ways to change this orientation just so it prints better. That one would be on the flat part, the big top part right here. And that will solve pretty much any issues we have with overhangs or anything similar. Or we could print it how you would write a T. So on this side, and that solves any issues with overhangs either. And then, so that solves overhangs, but you can still see how kind of efficient it is. So to do that, you'd hit slice in the bottom right. Here it would take 7 hours and 31 minutes and use 41 grams to print it in this orientation. And then if we were to change it, so let's say like this, slice again, it would take 6 hours and 40 grams. So like I said before, if you just change things around, you can cut off some of your time, save some filament or some material. And then it really depends on what you're using it for. Since it's just a T, uh, since it's or just a sample at this point, I can't really go into orientation on this one. But and you can save a lot of time just by messing with things in the slicer. And then the next one would be 45 degrees. So if you think about it this way, if you're printing at an angle, you want to put your first layer down, and then you're going to put your other layer down. But as you do it, there's going to be a little edge off of it. As you keep doing it, there's just going to be a little bit more overlap, or a little less overlap, I should say, as you keep printing. And then there's a certain angle that you would need supports at, and that ideally is 45 degrees. Anything greater than 45 degrees, you'd be safe, just because there's a little less overhang each time. Anything more than 45 degrees, you'd want to consider change the orientation or use supports, just because there's going to be a lot more material overhanging. Okay. Uh, let's see. And then for that, I'm just going to model a quick Y. Let's go into part. Start to sketch. Or not a Y, let's just do a simple triangle. Let's do that a 45-degree angle. It's not what I wanted, but I'll just do triangle. And then we're going to put another triangle inside. And then we're just going to extrude the outer part. Export, CAD format, STL, save. Open file. And I'm just going to scale one more time. 500. Okay. So here we have our V. Now you could print it like this, but let's change the orientation just to make it quicker. So we can print it upside down as a triangle. That's going to take 2 hours, or 2.5 hours. And then because it's at a 60-degree angle, won't need that much, we're pretty much safe. Or you can print it just flat like a V. which is going to take 2 hours, knock 30 minutes off. But just for the sake of teaching, I'm going to show the supports. So if you wanted to, you could print it like this. And then all you need to do is go into your settings, support, generate support, and then from there, you just hit slice. It says 2 hours and 30 minutes, and what we're going to do here is we're going to hit preview. And what preview does is it shows how how it will print. We're just going to start at the bottom here. And just because this is all at a 60-degree angle, it's not going to need much support except for the bottom just to get it to stick to the bed. But from here, you go slowly up. Let's see if I can do it. Alright, but from here, you can see the layer by layer forming just until you get to it's done. Right? But I think because my setting, okay, here we go. Support overhang angle. Go to 50. I want to try and get it to show supports. It's not going to show supports on this one. Okay. So we'll just close that. So that's one way to deal with overhangs. Ideally, if you can, do it first. Change the orientation first. And then I use supports as a last resort, just because it saves me time on having to clean up the print. Because what supports are is they're literally just other structures that you add in to, I don't want to say support again, but to support where your overhang or where the overhang material is going to be. That way it has somewhere to print on. And then along with overhanging, you're going to get bridging. And bridging is defined as the extrusion of material that horizontally links two raised points. The way I describe it is basically an overhang between two raised points, such as between two different points, such as in this picture where you have the material bridging across each other, where the only place it has to print on is going to be your points A and your points B, with nothing in between. And the problem with this is that you can experience drooping because there's no material underneath it for it to support itself. So solution to this, again, get a better printer, but not everyone can do that. So the best one for this would be for supports or change orientation. I say supports first because with any type of bridging, it's going to be either inside or it's going to be hard to change the print without losing some sort of strength to it. And a good example for this would be, I'm just going to model a table in Inventor real quick. Save part. So let's just do a simple table, simple 100 by 200. Let's 10 millimeters. Start a sketch on this one. by 20 millimeter. And then from here, I'm going to cheat a little. It's 100, so 80. Let's go in one direction, so 180. Finish those. So that's 10. Let's do 90 millimeters thick. I'll do this all at the same time. So here we have an upside down table. Just export real quick as table. New project going. And just make it big down here. So here we have our table. Now, if I wanted to, ideally easiest way, just like that, take 6 hours. Or if I wanted to, just for the sake of teaching, I'm going to print it, I'm going to orient it like a table. And then I'm going to hit slice, and another 6 hours, preview, just like that. Now the problem here is that when you actually go to print it, when it comes to this part might be a bit droopy, and it might not, at this part, it might even fail just because you're trying to put down a lot of material, but there's nothing for that material to stick onto or build upon. So you're literally trying to build on something that's not there. So ideally, if you want to print like this, you hit generate support, slice, and here you see these rectangular structures. On here you have grid, and that's going to be your support. Now, later on, you can mess around with how your supports are printed just to make things print easier, make them easier to remove and use less material. But in my opinion, if you can avoid using supports altogether, that's going to be much better. And as you can see, adding supports uses more filament and turned a 6-hour print into a 20-hour print. And it just being, so when you do this, do mess around with how you orient things, just because that will save you time, save you material, and if you're doing it at the makerspace, it will save you money. They do have student advisors there that will help you, but if you can go in, get your thing done, and have your print ready, you don't have to spend much time in there, even though it is kind of fun in there. But that's the big things you want to learn in the slicers. Things like how to move and rotate things come pretty naturally. But when it comes to considering how to orient your prints, and whether you should use supports or not. That's something they don't really teach you, or something you'd have to kind of learn on your own. And then that's pretty much all I had for slides. So just to sum it up, when it comes to 3D printing and slicers, the three things you want to keep in mind are how you orient your print and how the print is going to be used, because how you orient it can change how strong it is. Then the next big things are going to be considering overhangs and bridging, just because they can affect how nicely your print comes out, especially if you're doing something that fits together. And it can also save you a lot of time on changing your orientation to avoid certain overhangs or bridging. And then that's all I got. The only other person here is Dominic. So, Nick, I'm not sure what you want to do about the project rubric.
So, I added it to the shared drive that everyone has access to.
All right,
So if you just want to pop in there real quick instead of changing screens
gotcha.
between you and me.
Uh, so just have to. I'm going to stop sharing a bit just because I have to go through my drive to get there.
Hmm.
Okay.
Okay, so yeah, as we mentioned at the start of this interest group, the project that we kind of came up with was a drone design. This rubric is available in the drive, as I said before. Um, the description right there says the goal of this project is to not construct a real drone, but rather just to design one and test and experiment with your knowledge in Inventor and 3D printing design. Again, the rubric has more specifics and all the information for you, but just in broad strokes, this project is not mandatory. We're not going to force you to do a project, but it definitely would be good experience. Um, Again, this project could be used to maybe fill up some resume real estate, as I said in the beginning, I think at the first meeting. Um, Part of the project is going to be like project progress reports. You're going to have to, make drawings and presentations for it. We're not going to make it too extreme. It's not going to take too much time for your schoolwork, but it's going to be enough that you're going to get project experience and it's something that you could put on your resume and talk about. Um, since there's not that many people here, I think I'm just going to leave it there for now. When we send the email out and this recording is made available, please read through this and reach out to us with any questions. Next week, um, when you read through it, you'll see there's you can either choose to design a realistic drone for like modern day or even a futuristic drone. Um, we ask that you please make that decision by next week is most preferable. If you need to wait 2 weeks from now during spring break, that's fine. We have some weeks built in um, to give us some extra time, but that's it. And then next week we're going to be choosing these projects, and we're also, I think, going to go into Inventor and just do a lot more uh, side things that you can do in Inventor. I think next week we're going to do like stress analysis and how you can actually use stress analysis on your designs with different materials within Inventor. So that's for next week. So You can either email us with questions or bring them next week. But I think that's it for now. Kevin, if you have anything to add, or
Concerning the project, not really. No, that's pretty much it.
okay, and you can take it away from there.
All right. So I guess I'll leave it off at the project since there's only really one other person here. So that's it for this session. Are we gonna have a session next week, Nick, for before spring break?
Yeah, it's probably going to be a short one. Probably just people officially declaring what type of project they want to do. And I think I'm going to do a quick thing on stress analysis and Inventor.
Okay. So for Dominic, if you're still listening, we're gonna have a session next week. But unless you have any
Uh,
questions or comments, we're
for
pretty much
the
done.
for the drone thing, I'm assuming it's just like the frame of the drone, right? Like what exactly?
Yes, so it's going to be just like the body, landing gear, however you want to design it, propellers, propeller orientation. It's purely creative, nothing electrical about it. Um,
Okay.
yeah, so it's purely design work.
Yeah.
Okay. I think that's it, right, Kevin, for this week?
Yeah, that's all I got.
All right. So
So
you can
actually, I'm gonna stop recording now.